CEO and one of the founders of EquipTest. Our corporation has been on the market of testing and measurement for over 25 years. We continuously work on creating new innovations for the testing and measurement industry. Our company's innovation, which we call SuperProbes Technology. The innovation of EquipTest has been granted worldwide patents from the United States to Japan. We can proudly say that SuperProbes can easily go up to 200,000 cycles in production environment. As the SuperProbes technology is assembled from backwards, we were able to significantly decrease tolerances between the probe parts. As a result, the agreement does not fall apart, and another advantage is that the contact is much more precise. Practically, we successfully reduced the wobble effect to the physical minimum. It cannot be reduced further. One of the main users is Harman, who manufactures automotive electronics for well-known brands worldwide. They use our SuperProbes technology with high satisfaction. Their initial feedback was entirely positive and very encouraging. From the late stages of prototype testing, Harman supported EquipTest to successfully develop this top-quality test probe technology. And we can achieve excellent top-quality results from it consistently. I'm Tibor Pataki, the head of testing here at Pixie Harman. I've been aware of the EquipTest for quite a long time now. It was around the year 2006 when we had the opportunity to visit you at your then newly built manufacturing hall. I was genuinely very interested in discovering the motivation behind it. Can you explain how you discovered that specific problem that required a new and innovative solution? In this field, we can say that I have global experience. I have worked extensively as a test engineer and also took on leadership roles, gaining valuable experience while working abroad for several rewarding years. And of course, I also worked abroad in Finland, Mexico, and other countries. That the needle is not being guided properly, which ultimately affects the overall accuracy of the hits. With an area where various types of contaminants may potentially enter the needle, valuable components that contribute to its efficiency and functionality can also be lost from within the needle, which ultimately ensures low resistance and optimal performance throughout its use. It all leads to the ruin of the needle. The problems of side forces and contaminations can be easily recognized even by eyes as the gold. If we discuss a gold-plated needle, we notice that the gold layer wears off completely on one side due to regular use. If there happens to be any additional type of coating applied to the needle, signs of wear and deterioration are also noticeably visible in that area. In electrical measurements, achieving low resistance and high accuracy are always extremely important. The standardized SuperProbe, which features a notably low resistance value of 58 milliohms, can play a crucial role in significantly stabilizing the various testing setups utilized in the laboratory environment, ensuring accurate and reliable results throughout the testing process. This approach fosters a significantly more reliable and sustainable relationship when compared to our competitors in the industry. Your compelling description at the beginning truly convinced me that we genuinely want to be involved in this endeavor in some way. This specific process means that you carefully assemble the needles in a reverse order for optimal functionality. It can actually move in a significantly more precisely guided and controlled tube for enhanced accuracy and efficiency. The needle of the test is guided by the cylinder from which we lead out the moving part, allowing it to move much more precisely in a tube, essentially. This makes it more resistant to all kinds of effects. Therefore, the mandatory guiding path that is intricately designed within the needle's construction significantly helps to enhance precision and improve overall accuracy during its use. There are certain occasions when, due to various types of contaminants, we need to carefully break through that thin layer that effectively works against achieving a good and reliable contact. This step is essential to ensure optimal performance and functionality in the process we are undertaking. This is when we pull the product down 2 or 3 times, and only then does the test sequence start. In our plant, there is no need for retest when we use the SuperProbes. We are currently at 200,000 cycles put into these SuperProbes. It might actually be a bit more than we anticipated, and we still haven't needed to touch or replace those items. Preventive maintenance cycles at traditional test probes are preset. They could be 20,000, 40,000, or alternatively 80,000 cycles. We usually set this at about. Traditional test probes can endure approximately from 2,000 to 4,000, or in some cases a maximum of 8,000 cycles. In comparison, the equivalent of the SuperProbe model can effectively stabilize about. It can stabilize 40,000 cycles. I believe that the SuperProbe also extends the lifespan of adapters made with old traditional technologies. However, the full range of benefits and added value that it provides to the adapters can be best maximized when utilized with a completely new and specifically designed adapter. This ensures optimal performance and compatibility, enhancing the overall user experience significantly. I believe that the SuperProbe certainly has a significant role for products specifically engineered to meet high operational demands and rigorous performance standards in various challenging environments. In summary, we can say that the SuperProbe can operate for at least 5 times longer than other technologies. I hope it might go until 6 or 7. Let's give this option a chance as well. Our examinations gave us very positive feedback about SuperProbes technology.